Okay, let's have a look at compounds and how we represent them. So a compound is a substance that contains two or more different elements, and these elements are chemically bonded. We can't just have them sitting together and they don't interact, otherwise we would have a mixture of some type. Now, these compounds can be chemically but not physically decomposed into other compounds or elements. So in other words, we can't separate them through physical means, something like gravity or filtration or chromatography. Instead, we have to have a chemical reaction take place such that it changes the structure of that compound. So atoms of compounds are combined in whole number ratios always. And this is because we can't get half an atom. We've already said that an atom is the simplest form of matter, therefore we must get whole atoms. So we've got two different types of compounds. We have what are known as ionic and we have what are known as covalent compounds. Sometimes you'll see covalent written as molecular compounds. Now they differ in terms of what type of bonding takes place between the atoms. So if we take our ionic first, our ionic compounds are made of ions, which will be an atom that either has a positive or a negative charge, and the positive and negative attract each other. And this forms what's called an ionic bond, which means that it's an ionic compound. An example of this is a sodium ion that's attracted to a chlorine ion that forms sodium chloride, which we know as salt that's used in table salt. By contrast, our covalent compounds don't readily form ions, so they're not positively or negatively charged. Instead, we get an interaction between the electrons in some other way. And that's often referred to in a model where the electrons are shared between the atoms. So we have an example of our water, H2O. We've got two hydrogen atoms with an oxygen atom. Essentially, the model says that they share those electrons between the different atoms. So let's have a look at how we represent a chemical or a compound with a formula, which is a shorthand notation for representing a long name. So we always represent the ratio of elements in the compound. So if we've got a diagram which is similar to the previous one, we have two atoms here that are the same, we have one different one. So this could be an example of H2O or water. We have two hydrogens and we have one oxygen. Now, to get our chemical formula and to make it meaningful and transferable to someone that might be reading it, we have to set up a few rules that we need to adhere to. First of all, the formula should contain all the symbols. In other words, it should contain all the elements of that compound. So you'll notice in the previous example, we've got H2O, we've got hydrogen and oxygen. They are the only two elements that make up water, so they must be represented. Secondly, when one atom of an atom is present, just the symbol is written. So if we go back to our previous example, we had sodium chloride, sodium and chlorine, it's one atom of each element, so we don't need to write that there's a 1 there. Instead, the symbol is enough to tell us we've got one atom only. If, on the other hand, there's more than one atom of an element, we need to represent that with a subscript, so a number below our element, to represent the number of atoms that we've got present of that particular element. So if we take an example here, our sulfuric acid, which is H2SO4, we see that we have two hydrogens, so the subscript is after the element. If it was before, it would mean the previous element. So it's always written after the element, or the symbol for the element. So we have two hydrogen atoms. We have 4 oxygen atoms. So this particular molecule has 4 oxygen atoms, 2 hydrogens. And we'll notice our sulfur here doesn't have a 1 in it. So we said previously, if there's only one atom present, we don't need to put that subscripted 1.